when, okay, meaning we're interested in the mitochondrial membrane potential because that a lot of times when the mitochondrial membrane potential is depolarized, they will release cytochrome C and it will release the apoptosis initiation factor, okay, and that is part of the pathways that initiate apoptosis. So you can measure the mitochondrial membrane potential in the investigation of apoptosis. Okay? That is one of the relevant parameters to investigate. And also, with respect to the energy metabolism, the mitochondrial membrane potential also regulates the proton gradient that is used to generate the ATP by oxidative phosphorylation. Okay. So you can have a measure or a gauge as to how involved that process is in the cells by measuring the mitochondrial membrane polarization. For example, if you use the methodology of the fluorescent dye, for example, the JC1 dye, and looking at the ratio of the red and green fluorescence, the red and green fluorescence measurement, you can do it in different ways. Okay, you can measure the red and green fluorescence that are in individual cells, okay? Or you can just look at the big picture and measure the red and green fluorescence of the whole cell population. Okay, but knowing that you're going to have a distribution. Some cells have lower potentials, some cells have higher different potentials. Unless you want to look at individual mitochondrial potentials of a single mitochondria, in that case, you would need to have a purified mitochondrial preparation. It's microtroops to actually stick the electrode into the membrane for measurement of the potentials directly using the what do you call it, the electrophysiological type of equipment for microelectron measurements. So that would be the direct way of measurement, but that's highly technically difficult.
I have a question about rapamycin. You said that last week you said that rapamycin is used in chemotherapy to treat cancer. But I also know that rapamycin is also an immunosuppressant, and the side effects of the immunosuppressant is higher chance to get malignancies and inflammation. My question is, how can it happen? Because it seems conflict.
Well, depends on when and where things are applied. Things that happen in different sequences. If you have inflammation in the context of cancer, it's different in different contexts. For example, inflammation in the cancer initiation stage. For example, smoking or carcinogens causes irritation of mucosa. Then in that inflammatory process, it's helping to transform the normal cells into a cancer. Okay, so in that situation, if you suppress the immune system in that stage, you would be able to achieve the purpose of cancer prevention. Whereas On the other hand, the immune system is able to detect abnormal cells and have the immune system to get rid of the abnormal cells once they get transformed. So the immune surveillance system is important to block the formation of cancer. And then one of the cancer hallmarks is the ability to escape immune surveillance. So if you knock down the immune system at that point, you actually facilitate the formation of the cancer. So it is not conflicting, that it's just that different processes place different roles at different points of time in this process. And after the cancer is formed, okay, for example, in melanoma, if you need to treat the, now one of the most successful treatment for melanoma is the immunotherapy. In these cases, you actually give drugs to boost the immune system to detect, so that the body can detect the melanoma and continue to fight the melanoma using the immune system. So in these cases, if you're doing immunotherapy, you do not want any therapies that would suppress the immune system to be ongoing at the same time. Okay? So in the cancer treatment, that's why the cancer treatment is very complex and need to be planned. Okay? And different drugs can be combined with different drugs together. Some drugs can be combined together, some drugs cannot. For example, you cannot combine the glucocorticoid or immune suppressing drug together with immunotherapy, right? But you can do it sequentially. You can do cytotoxic chemotherapy and to reduce the tumor load. Okay, you can use drugs that would also suppress the immune system, that toxic to the cell, and kill the cancer cells, so decrease the tumor load. So when the tumor is very low, okay, at that point you stop those drugs, and then now switch to immunotherapy. You boost your immune system to continue to finish up the job. Okay. So these things still need to be planned and played out and tested in order to see which is the best way, both in terms of dose, in terms of time, in terms of combination. It's very complex.